Hey guys, so for the final math project for Calculus 2, Mr. Chouikha told me to make a wheel rim using AutoCAD and like calculus methods, so this is what I tried to do. So I'll be showing you guys how I made this wheel rim using calculus methods. So first I started off by making sure I had the right planes. In AutoCAD specifically, it lets you designate between X, Y, and Z. I started in an XY plane because that was the easiest for me to start off with. So what I started off with was an equation of the line. They're all just linear equations. It's a lot. The problem with AutoCAD because I've never used this software before, is that I could not figure out how to directly put in equations. I could only put in lines onto there. So the best way I could use to express any of the lines here, because they are technically equations, you just can't put them into the program like Desmos can, and that's not something that I knew how to do. So basically, if you look right here, this is kind of like an example of what the equation would look like on here. It's just not the exact equation, it's just a very similar line. But yeah, so that's what it would look like in Desmos. And basically what I did for that was I revolved it around this axis. And integrating calculus into this is the same thing as revolving curves around an axis. So you could use volume, or use it to find volume using integrals. So basically, when I made this is the original, just revolving the single curve around there, this entire line right here. It's about 250 lengthwise in millimeters. So what I did there was I took this and increased the thickness by about 4 millimeters, I want to say, so that it's a little bit stronger. But when you do that, it's no longer just this equation. You have a little bit of a gap in between now, which instead of using just like volume by shells, you have to use the washer method in order to do that. And the reason why I did that was, let's see, if I uncover this part, these are the exact same equations for those. Instead of just having this original blue line to find the integral, the volume of that of the outer rim of it, you would have to use the washer method instead. So it would be this outer radius minus this inner radius. So like the integral of that is pi times outer radius squared minus inner radius squared, and that's how you use it to do that. For this is just me changing the color. And then this is where it gets a little more complicated. In order to make the front portion of the rim, I had to designate a plane. So I just took a YZ plane and I moved it to the left a little bit. So that's what happened right here. And I put it right where this little intersection is right here. So there's still a little bit of a space for that. And this is just it changing into a sketch mode. In order to do this part, I basically just made like circles, so it would be easy equations like, let's see if I can bring one up in AutoCAD, or in Desmos. So basically, if you were to just take this is your normal, just like r equals 1, I don't know why that says 0, 1, but x squared minus y squared, and that's basically all I did to designate this part. I made this part in order to make the inner part of the rim. So if you go back to the beginning, it was like this part, that's how I made that inner part. And same thing for how to find the area of that is, since it's a circle, you have to think of it, since this isn't a 3D plane, it's no longer just x and y, it's x, y, and z. So you take that area, which is pi r, whatever the radius was in my program, but you take that radius and you find that circle, and then you'd find the integral from that, of that circle, and take it as far back as it needs to. And since it's 4 millimeters, you just go back 4 units. So from like 0 to 4, that's what the integral would be, to find that volume. Then in order to do this part was a lot more extra than I anticipated. So I had to make an axle originally in order to make this outer portion of the rim complete. So what I did was I just made this rod. This rod doesn't really have any purpose other than like a space filler to combine later in order to make the holes of the rim, which I shall show in a little bit. This is me designating those curves. This is me taking the XY plane again and then doing it like this. So if you were to look at this from this point of view, it's the XY plane. This is, the edge of this is like the original curve that I originally showed in this very first slide. So that's basically it revolved, and it's showing it that in this plane instead. So this is me splicing the graphic, and splicing means it just cuts it in half so you can see what's on the inside. And this allows me so I can draw more sketches and like lines and equations onto the program. So in order to make these little rim things, so it's the place where you'd usually put in the bolts into the wheel, I made very simple equations. They're all linear equations, similar to how we did it before, and you do that area the same way. So it would be this, since the bottom line of this is already the, like, y equals 0, if you were to think of it like that, you can just use volume by shells in order to find that area. And you just have to take it in by parts, similar to how you would find it for that original line. You can't just do this whole thing by one equation, since this is so many equations just to get to that point, like all of these. You just take it from each part. So since this one is like, let's see, so from here to here, it's about 10 units. You take this integral, so this outer radius minus this outer radius, or minus this inner radius, from 0 to 10, and then continue that for each individual function. And that's similar to how you would do it for the little bolt holes right here. And I just revolve those around to get those, and then I used a circular function in order to plant them into 4 other areas. So there's 5 bolt holes in total. Now for this part, after I made the holes for the screws and bolts, I designated another XY plane, and I sliced it again. This part is a little more tricky. I used just general splicing lines to find that. Similar to the equations, you do this from this angle. So if you were to rotate this to the right a little bit, you could do outer radius minus inner radius to get that volume, which is very similar to how we did it earlier. But after taking this equation, basically, you rotate it along in this motion to get this outer face right here. And you can see where this axle comes into place. So you have your 3 little bolt holes. And eventually when you combine the two, it'll remove this part from the original, and you'll get the little holes that you wanted originally. Lastly, in order to make the little holes or the rim design on it, you need to make another XY plane, I believe. No, it's a YZ plane. And then designate a new sketch on that portion. Now in order to do that, basically, I made a bunch of lines that go in every single direction. They're just all linear equations, so they're very basic. And these aren't included in you don't really need them to find the volume. It's just like a boundary for you to make your actual equations. So for this, basically what I did was I did portions of polar equations. So normally your roses would look a lot different. So over here I can show you, let me just make these disappear. So normally it would look, or when you do a flower, let's say I removed this part. So normally your petals would look like this, but if you were to put it over one, it inverts it. And then adding this makes the distance from the center a lot greater, which is helpful in our terms because that's what we need to make these. The only difference is that in order to do this, for my equation specifically, I made asymptote on these, so there would be a line like right here cutting it off. But yeah. And then that's how I did it. I just combined it and then used the circular function to make sure all the holes went there, and that's how I made the entire wheel. And that's the completed wheel, basically. And in order to find those volumes, you basically did the same thing where you could use arc or area between an arc using polar equations, using the same radius, and you'd find one of those, and then you multiply it by 5 to get those. Then once you have that area, since that's only like one portion, you take the integral from 0 to 4, since it's 4 millimeters deep, and then you'd find that volume. And then the program itself actually does give you the area and volume, so all the things that I described are the methods in how the program itself finds the volume. Other than that, you could also find specific things like mass depending on the material that you decide to use in the program, but generally those are all the methods. So I hope you guys enjoyed that, and thank you.